Okay, so this is the second question. The first one was something that you haven't really seen before, but the second one here is like you're going to apply something that you've done before, that being the quadratic equation. Right? So, first things first, though, let's start out with the equation. Actually, let's take a look at the equation. So right off the bat, you can see that the equation is written in a different form, right? So it's no longer vertex, it's in standard form. And so we need to do different processes dealing with standard form than we do with vertex form. So, but for part A here, it says it wants you to determine the height of the ball after half a second. So that's not unlike the first question, or part A of number 1, right? So we've got X's and Y's, right? That's just the last one. And basically that turns into T and H. And it wants you to find the value of H when T is 0.5. Okay. So just a different looking, it's a different equation written in a different form, but the process is the exact same. So I'm going to take H equals negative 4.9, and then I'm going to replace T with 0.5. Okay, and you just do the math on that. Now, turns out that H is equal to negative 4.9 multiplied by 0.25 plus 8.4 multiplied by 0.5 plus 1.5. And it turns out that H is equal to 4.475 meters, right? So therefore, after half a second, the ball we'll say above the ground. I'll move this up so I get some more room here. Ball is for above So after half a second, the ball is 4.475 meters above the ground. Now, should also be noted that if I were to plug in, and this could be a question I ask you, like this could be part A of a different question. If I asked you from what height was the ball thrown, well then you could go H equals negative 4.9 multiplied by 0 squared plus 8.4 times 0 plus 1.5. It's 0 because before the ball gets thrown, the time is 0, right? So you can see that this cancels because 0 times all of that is 0, and this also cancels because 0. And it turns out that the height at which this particular ball was thrown was from 1.5 meters. So it did something like this, right? It came back down. That's going to be important after for interpreting the results, but just so long as we're aware of that, should eliminate some confusion later. So I'm going to leave this picture. I'm going to leave this picture right here for now. We don't need the H. Okay, so that's important. We'll come back to that picture later. Put little blue blocks around it or something. Okay, so that's part A. Very similar to number 1, like part A and number 1. So I know I'm not going to have enough room, so I'm just going to shoot down here for a sec, okay? So it asks me, after how many seconds does the ball land on the ground? Round to the nearest tenth, okay? So I have this equation. It's H equals negative 4.9 t squared plus 8.4 t plus 1.5. Okay. Now, how many seconds does the ball, or how many seconds is the ball in the air before it lands on the ground, right? So the word ground implies that, again, h equals 0. Right? And so I can just say, okay, well, that's going to come down here. It's going to be 0 equals okay. Now, this looks very familiar to something that you've seen before. It's a trinomial. And we could check. There's a few different things we can do to trinomials. We can factor them. We can throw them into quadratic equation and get solutions, right? So let's check and see if there's what's factored, because factoring is obviously nicer than using the quadratic equation. Quadratic equation is always your last step, right? So with this, we'll see if we can factor it. We're going to need two numbers that would have multiplied to. That's going to be a number, whatever that number is. And then I also need two things to add to 8.4. And then you would have to come up with the two numbers that satisfy those conditions. Well, these look pretty ugly. I don't like this, right? I don't think you're ever going to find two numbers that satisfy this perfectly. And so because of that, you are forced to use the quadratic equation, right? You're just stuck using it because you can't factor it. So with that being said, let's do the quadratic equation. So if you recall, quadratic equation takes the form of negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And then if I were to write on the side here, a would be equal to negative 4.9, b would equal 8.4, c would equal 1.5. And if you're wondering where I get those numbers from, they're just from here, right? Because we remember standard form takes on the form of, right? That's what standard form looks like. So they're all the coefficients in front of the variables, right? So with now knowing what each of those are, I can plug them in to where it tells me to plug them into on the quadratic equation, right? And so I'm going to get negative 8.4 plus or minus the square root of 8.4 squared minus 4 times negative 4.9 multiplied by 1.5. Okay, and then all of that is divided by 2 times negative 4.9. And there's a reason why you don't want to do this. You prefer to factor. Although this will work every single time, you don't want to do this every single time. You only want to do this in the circumstances in which you're stuck. So it turns out that when you simplify, well, let's take a look at here. So the way I've written this here is very important. You write it like this so that the signs work out, right? Because we said if you got a negative number underneath the square root, remember when we looked at the discriminant, if we got a negative number under the square root, that meant there was 0 solutions, right? So we want to avoid that, and we want to avoid making that error, because if we get a negative, the parabola looks like this, or it looks like this, and it never crosses the x-axis. Therefore, we have no solutions, right? No solutions, right? And so we want to avoid that, and we want to avoid making that mistake. So I always put the brackets in like this, and then I'm very careful from that point forward, right? So, and these are t equals, by the way, because we're obviously solving, we're not obviously, but we're solving for time values, right, that satisfy left side equals right side, right? So in this case, 0 equals 0. I'm looking for the t values that make the right side 0, right? And that's what the quadratic equation is going to spit out, right? So it turns out that if you do the math on this, if you do the math on this green section, right, the piece underneath the square root or the discriminant, if you do the math on the discriminant, you get the square root of 99.96, and that's divided by negative 9.8. Okay. And so from there, we just do the rest of the math. So I square root the 99.96, and we're going to get t equals negative 8.4 plus or minus 9.998, and that's all divided by negative 9.8. Now it's at this point that you get to split the quadratic equation to two answers. You get a positive answer, or an answer from doing plus, and you get an answer from doing the minus, right? So I'm simply just going to do negative 8.4 plus 9.998 divided by negative 9.8, and I'm going to get negative 8.4 minus 9.998 divided by negative 9.8. Okay, these are t equals. So it turns out that t here is going to equal negative 0.163. Okay, and it turns out here that t is going to equal 1.877. Okay, so these are the two values in time in which this ball is in the air, right? So sorry, how long it takes for the ball to hit the ground. Okay, so therefore I would say, therefore it takes 1.877 seconds for the ball to hit the ground. Now, you might ask, well, what about this other answer that's up here, right? What's this? Well, for every quadratic, you know that there has to be two answers unless the vertex lies on the x-axis or there aren't any answers at all, right? So this is just the other solution that satisfies the left side equals right side scenario we were talking about, where the right side equals 0 when I plug in this value of t, right? Now, because we're talking about time, we can't have negative time. That's not allowed, right? Doesn't make any sense. It's not allowed. So we can't have negative time, and therefore you get to disregard this answer when talking about how long the ball is in the air for. Okay? So, with that being said, we can move on. We now know how long the ball is in the air for. We can go back and figure out part C, right? Well, part C is asking me what's the maximum height the ball reaches, right? And typically, if I see the word maximum in the past, there was something I told you to do, and it was complete the square. However, if I ask you to do all of this work, I wouldn't then expect you to do all the work for completing the square as well, right? And remember what completing the square did. It changed a quadratic from standard form two vertex, right? That's important because then we could read the vertex off, which ultimately meant the max/min value, right? You could do that, but there's also a second way to do this question, and we talked about it briefly before the break when we were plotting parabolas from standard form and just finding points and then being able to plot the parabolas that way. We could factor the equation, find the roots, and then we found this is my parabola. Went up and came down. I could find out what the two roots were, and if I found the middle, we called this the axis of symmetry, right? If I found what value of t was the axis of symmetry, I could then therefore find the corresponding height value, like in part A, right? So, turns out, from this question, from part B, I found out what these two values were, right? Turns out that the one on the left would have been -0. I'll fill this in over here. -0.613. 163, and then over here we found the value to be 1.877 seconds, right? Now, if I were to find the middle of those two values, that would tell me the axis of symmetry, which would be useful. That would be how long, right? Tells me how long it took to reach the maximum height. Right? If I know how long something takes, I can then find what the maximum height was, right? So, let's do that then. So how do I find the middle of the roots? Well, I take -0.163, I add it to 1.877, and then if I divide those by 2, that gives me the middle of them, right? So it turns out the middle of the roots turns out to be 0.857, right? So therefore it takes 0.857 seconds for the ball to reach its maximum height. But that's not what the question's asking. Right? If we look back up here, what is this question actually asking for? If we go back up, what is the maximum height? Okay, well, we know how long it takes, right? So if I know how long it takes, that's this point right here, the t value there, right? If I take that t value and I plug it into my equation, right? You remember that the equation was -4.9 t squared plus 8.4 plus 1.5. If I take this t value and I plug it in to t, it's going to tell me what the height is, right? So I'm going to do that. So I'm looking for the height. H equals -4.9 multiplied by 0.857 squared plus 8.4, 0.857 plus 1.5, right? And if I do the math on that, it turns out that H equals 5.10 meters. So therefore, the max height the ball reaches is 5.10 meters, and this takes 0.857 seconds. Okay, that's the end of this, right? You guys should be able to answer some questions about basically what we've done in this lesson. Can you tell me how far a ball goes? Can you tell me what height is it fired from? And can you tell me what the height of anything is after some amount of time, right? You should be able to do all of these things, okay? And now we're really taking what we learned about discriminant and the expectation of an answer, and we're putting that on top of using the quadratic equation in order to actually give me numbers that mean things to a word problem in real life. Okay, so that's the application that we're going for today. And then feel free to message me for any questions you might have.